Then after the next topic, that is conservation of momentum. See, in chapter number 1, we discussed the conservation of physical quantities. Means in nature, during some phenomena, some physical quantities remains constant. Means it does not change with time. Then we say that physical quantity is conserved. And some conservation laws are there in the nature due to some symmetries in the nature. So in chapter number 1, we mentioned 4 conservation laws: law of conservation of energy, law of conservation of linear momentum, law of conservation of angular momentum, and law of conservation of charge. And I mentioned this thing. All these will be discussed one by one in detail in standard 11th and 12th. So out of which, now the first one that we have to discuss here, conservation of momentum, or it is also written as conservation of linear momentum. Whenever the word is used momentum, then by default it will be considered as linear momentum. Whenever angular momentum will appear, specifically the word angular that will be used. Okay. Now, law of conservation of momentum. The total momentum of an isolated system of interacting particles is conserved. Or in other words, we can write this one like this: in the absence of resultant external force, the total linear momentum of the system remains constant. Okay. Now see here, let's try to understand this thing. Suppose we consider two objects, A and B, and suppose the initial linear momentum of A and B are vector PA and vector PB respectively. Now, when these two objects interact, and after the interaction, suppose their final momentas are PA dash and PB dash. So we can write the change in momentum of A, that is PA dash minus PB dash, this one. But change in momentum of A, that is the impulse on A. So that is force on A by B into time interval. Similarly, change in momentum of B, that is final PB dash minus initial PB, but that is also the impulse on B, that is force on B by A into time interval. But as per Newton's third law of motion, we have force on A by B equal to minus force on B by A. So here multiply both the side by delta T. So we can write vector FAB into delta T minus vector FBA into delta T. But here we can substitute the values of FAB delta T and FBA delta T. So first one, that is PA dash minus PA. So left hand side is replaced by PA dash minus PA. And right hand side is replaced by PB dash minus PB. So we can write PA dash minus PA equal to minus PB dash plus PB. So PA dash, take this PB dash on left hand side. So PA dash plus PB dash on left hand side. Take this PA on right hand side. So on right hand side we will get PA plus PB. Now see, PA plus PB, that is the summation of initial linear momentum of A and B. So we can say this is the total initial linear momentum of the system. Means before interaction, initial means. Then on left hand side we get PA dash plus PB dash, that is the summation of the final linear momentas of A and B. So after interaction, this one, right? And see here, when this summation here appears, means that is the total final linear momentum of the system. Means after interaction, મેં કહ્યું તમને. So total initial linear momentum of the system and total final linear momentum of the system both becomes equal here. So we can write total linear momentum of the system after interaction between the particle, that is equal to total linear momentum of the system before interaction between particles. Okay, so initial total linear momentum of the system, that is final total linear momentum of the system, which represents the law of conservation of momentum, means the momentum that remains constant, same one, or we can say momentum is conserved. Okay, clear to all of you?